Hey, so today I'm gonna do a tutorial on how to inject code into a binary file um, on the Linux platform. Now Linux uses something called the executable unlinking format. So ELF, the ELF file, ELF binary, and basically what ELF is it's a format that describes how to execute binaries on a Linux system. And if you do a man elf on your Linux system, you will see a bunch of information about the elf and structures, data structs that you can access if you include the elf header file. Now, the reason this is useful is a lot of protection programs will actually, you know, inject code into binary files and then encrypt what they'll do is they'll encrypt the binary file and inject their own kind of loader code into the binary file that unencrypts the file when it's run. So it's good to actually understand what they're doing, methods to do this. Um, Other things that you can do with injecting into binary files is you can backdoor binary files without the source code. So maybe you're on some kind of proprietary system, uh, some Linux system with proprietary binary. You don't have the source code to it, but you have write access. Uh, you can backdoor it this way. It's also a method that virus writers have been using for years. This method I'm going to show you today is very simple. It's kind of not really reliable in that there's a lot of caveats which we're not really going to go into that could crash the executable that you're trying to backdoor or trying to inject code into. But I'm going to show you how to do a basic code injection technique. And the way we're going to do that is we're actually going to examine the binary file and look for a string of zeros. So basically, somewhere in the file where there's no code, there's no data, it's a bunch of zeros that we can use to put our own code in. I'm going to use a simple hello world binary we're going to write here. So let's just quickly write this. This will basically just be our test file. Be super simple, one line. Alright, now I'm going to show you a program that's useful that you probably have already installed on your Linux system. It's called readelf. So as the name implies, it reads ELF files. So it reads Linux binary files, and it'll give you a bunch of useful information on that file. I'm going to use the -e switch and then put our binary, which we call T. Gives you a lot of information. For now, we're just going to be concerned about one piece of information, which is the entry point. So the entry point address, 0x400400. Now we've seen this before. We know that the entry point is the very first instruction to be executed in our binary file. And we've looked at that in GDB before, and we've seen how we can actually retrieve that from within GDB, and I'll show you that again really quickly. So GDB, let's rename this file. Call it test file. So the info file command within GDB will give us the same entry point, 400400. Now let's put a breakpoint on that. And we're going to run the program. So it breaks. Again, this is the very first instruction. This is the entry point. And if we look at our instruction pointer, you'll see that's what the entry point is. So it points to the very first instruction to be executed. And this is the first instruction. It's going to be an exclusive OR. So what our plan of attack is, we want to actually be able to modify this entry point. We want to modify that to point somewhere else in the code. somewhere else in the binary where we find a bunch of zeros that we can put our own code in. So the short-term goal is to modify that entry point to something that to anything else, so something we can control. So, how do we modify that entry point? It's very easy on Linux. Again, the man elf will show you. But we have the very first bytes in any kind of binary file for an elf binary will be the elf header. The elf header is always at offset 0, the file. Now, included in the elf header is a field called e_entry. As you can imagine, that's the entry point. Let me just show you. So e_entry. This member gives a virtual address to which a system first transfers control, thus starting the process. So, virtual address. Now, virtual address basically is the address in memory. You have file offsets, so the address on the file on disk, and then you have a virtual address, which is the address in memory. They're different. And there are ways to translate from file offset to virtual address, and vice versa, and I'll explain that to you. But for now, let's just try to change that entry point. Now I'm going to show you some real basic code, how to do that. So as we've seen, we've got to include elf.h, that's the elf header file. I'm going to be using open, so I believe I need sys_stat.h. I think I'm going to need this. I'm definitely going to need this. I think that may be it. So now what we're going to do, we're going to need an elf header structure. So remember we see on the man page, elf 64_e header. Now I'm on a 64-bit system. If you're on 32-bit, you would change the 64 to a 32. But that'll give me a 64-bit elf header structure. And now we're going to open up the file, get a file descriptor. We're going to use argv1, so the first argument to our program is we're going to try to open. And we want to have read and write to it. So now we're going to read from the file descriptor into the address of our elf header the total size of our elf header. Then we'll print out the entry point. Oops. Alright, let's try to compile that. I think I missed a header file. Of course I did. Okay. Try again. Now, we know that the header file, or the entry point was 0x4040, or 400400. So let's see if our program does indeed read that. So it does. So it's that simple. Entry point 400400. Let me show you the code again. So you already have that defined elf header structure for you. It's an elf.h. We're just reading into that address the first, size of elf header bytes into the elf header, and now you get access to all those fields. The one being that we're interested in right now is obviously the entry point. So now what we want to do is we want to write it back. We want to write a different entry point. So let's just do something like this. The classic instruction pointer. And now what we've got to do is we've got to actually seek back to the beginning of the file, because remember the elf header has to be at the beginning of the file. And once we do this read here, we're actually moving our file pointer past the beginning, and we're moving it, size of elf header bytes into the file. So I've got to reset it back to the beginning. So that's what I'm doing right here. All it does is seeks a certain position on a file descriptor. So seek on this file descriptor, starting from 0, or sorry, 2, 0, the 0 location, very first offset 0 in the file. Seek set, meaning to seek from the beginning. Seek set from that beginning. So we're going to wait to 0. And then we're going to write to that file descriptor the elf header, size of the elf header. Now if we run it again, oops, I didn't give it an argument. So the entry point is still 400,400 because we print that out before we modify it. But now that we've actually modified it, if I run it again, I should get our new entry point. So there you see we've actually modified the entry point to 41414. But obviously, we can put that to wherever we want. Now the next step is to actually find somewhere in the code suitable that we can inject our code into. So in that scenario case, what we're going to do, the method we're choosing to do, there's a couple methods, and I'll show you some more at a later time. But the method we're going to actually do today is we're going to find a sequence of bytes that have no data, so a bunch of zeros. I'm going to show you another program. It's called XXD. It does a hex dump of a binary file. So let's hex dump that test file. And you can see all the bytes in the file. Now if I scroll up, I'm looking for basic, so there's one right there. There's a little bit of a, an address with a bunch of zeros we could possibly write some code to. Here's a whole bunch, so right here. So this is ideal. I mean, there's a lot of zeros here. Now there's a couple caveats to keep in mind, which we'll eventually go over. For now though, we're just concerned with finding a place with sufficient space. This one here looks pretty good. I mean, there's a ton of zeros. Now, doing this by hand with XXD isn't going to be something that you want to do. So, I wrote some code to actually go through a file and find zeros, So I want to show you that code real quick. You may not understand it. It's not a huge deal. All you need to understand is this code will actually process byte by byte a given file, and then it will spit out the addresses of locations that have what I'm calling, what people refer to as a code cave. So a place where there's a bunch of zeros that you can actually place code into. Now, I've already written code. Actually, what I'll do is I'm going to end the video here so that I can actually get part 2 ready for you guys. But in the next video, what we'll actually do is we'll find that location programmatically, get the address, and what we'll do is we'll modify our entry point, to that address that we found, and we'll start writing out code to that address, injecting our own code, and eventually returning back to the original entry point. And the program should, run our code and then run the actual code as well, as if nothing happened. So thanks for watching, and I'll try and get that other video posted as soon as possible, and have a good day.